Alright, I want to take a look at our next topic being unit rates. It deals with the proportion idea, and you can use a proportion for it, but it ends up being not the most efficient way. I mean, you can set up a proportion and do the solving, but it ends up just being straight up division, okay? So I want to take a look at unit rates. The idea is, how do you compare things that are of two different values? For instance, if I have a quart of iced tea and a pint of iced tea, how do I decide which is the better buy? Well, you would have to figure them both out to decide what they're both worth for the same amount, if that makes any sense. So unit, the word unit, actually stands for one. And sometimes you see it in place values. The hundreds, the tens, and then they'll say round it to the nearest unit. What that means is the ones. So unit has to refer to us as one. So it means get one of something. So it simply can be done as this. $27 for 14 apples. Now again, this is the idea of a ratio, two things being compared to each other. I could write it as a ratio, 27 to 14, knowing that my label here is money and my label here is apples. So this becomes 27 to 14. Unit rate means you need to get it to one of something. So the question could be, what's the unit rate per apple? Okay, so I need to convert this down to a 1. So what's one apple worth? Simply said, it's going to be division. Well, this is $27. I need to convert down as well. So it's kind of the same as the cuts and pieces we did. We take the numbers and divide them down. So here's 14, divide by 14 gets me 1. So I take my calculator, no sense of doing the arithmetic on paper, and take 27, divide by the same number. So this was divide by 14. Do you need to show this? No. I understand what you're dividing by. There is no real algebra to show here. We're not using a proportion. So I just need you to understand what to divide. So 14 divided by 14 is 1. 27 divided by 14, probably get a decimal, is 1.92857, etc., etc., etc. What do we round to? Something that kind of makes sense. Well, if this is money, how do I round it to money? 1.9285. Well, in money, I get two places for cents. Okay, so go to the last digit, the singles digit, the ones digit, the pennies. Oh, there's an 8 after it, so that's going to bump it up. So this would round to $1.93. So what is the unit rate for every apple? $1.93. That's the idea of unit rates. And I think the concept makes sense. We just have to specifically know, okay, what math do I do? Now, you can unit rate the other way. So it depends how the question is worded as far as what you unit rate or take down to 1. What if you unit rated this way? Oh, for every dollar, how many apples do I get? So I have $1. Hey, sir, selling apples, I want to get $1 worth of apples. So what's the unit rate? Well, 27 divided by 27 gets me down to the 1. You have to know what you're unit rating and then take it down to 1. So I'm going to do the same over here. Also divide by 27. You don't have to show any of this work because we just assume it's division. So 14 divided by 27 is 0.518. 0.518. Okay, how do I make sense of it? Well, round it. Okay, 0.518 of an apple. Well, that's roughly half. So 0.5. So you get 0.5 of an apple for every dollar. Again, this is unit rate. Let's take a look at the first example in your assignment. On 5 different keyboards, there's 725 buttons. So let's unit rate both of them. Okay, this becomes a 1. 5 divided by 5 is 1, so I take this and divide it down by 5. 725 divided by 5 is 145. So this means there are 145 buttons for every one keyboard. And again, I unit rated I took it down to 1. The keyboards, I took the keyboards down to 1. I can write it as a ratio. Sure, it was a ratio. This now is an equal ratio because I divided by 5. I'm going to leave that up and I'm going to unit rate the other way. So let's get him down to a 1. 1 button. Okay, what's 1 button worth? How many parts of a keyboard is only 1 button worth? Well, I would divide by 725. So I would divide this side by 725. It's going to be a real small decimal. 5 divided by 725 is 0.0068. 0.0068. Well, I got to make sense of it somehow, so 0.00, I got to get a number. I would round that to 0.00, I'm sorry, 0.01. And that's keyboard. So what is 1 button worth? It's worth 1/100th of a keyboard, roughly. Again, that's rounding. So again, this is unit rate. Figure out what you want to get it down to, which side has to turn into the 1, what you want the unit rate of, and you simply divide. What do I divide to get down to here? What do I divide to get down to here? The next part of this assignment is going to be to take different objects from a store and figure out the unit rate. So that way you can figure out what really does cost more per ounce. We need to get it down to 1 of something. So you could do by 1 gallon, or we could get it down to 1 ounce. I got 2 iced teas. I said this wrong earlier. This is half gallon, sorry. So half gallon and a pint. Okay, half gallon is 2 quarts. So you could ask yourself how many pints fits into 2 quarts. So it should be 4. It should be 4 of these fit into this. But the question is, which is the better buy? The 20 ounce, the pint, and again on there it'll say ounce, or if it's not, you can convert down. If you don't know, here's my gallon man and quarts and pints and cups. Now each cup is worth 8 ounces. So you can always get from gallons, quarts, pints down to ounces somehow. Okay? So if you figure out that there are 16 cups in a gallon, you could do 8 times 16 and hopefully get 128. So there's 128 ounces in every gallon. Alright, so what do we do? Unit rates means gets 1 of something. Okay, so I can't really compare these to which is the better buy. Oh, hey, I get more with this. Oh, but it costs more. So we use unit rates, and I'm going to take and get both down to 1 ounce. 1 ounce. And again, this is like the cuts and pieces project we did. Once you get it all down to 1 cut, you now know what each produces. So 1 ounce, 20 divided by 20 is 1. So I'm going to take $1.29 and divide by 20. And I get 0.0645, 0.0645. I need to make it into money. There's my cents. 4 keeps it down, so this is 6 cents. 6 cents for every 1 ounce. All right, let's check it. This is a better buy. 64, I need to get down to 1 ounce. And I'm going to compare it to the $1.99. 64 divided by 64 is 1. $1.99 divided by 64 is 0.031. Round to the nearest cent, and it's $0.03, or cents, sorry. So which is the better buy? Sure, the bigger one is the better buy. And this is why stores like Costco's and BJ's sell mayonnaise jars for this much. Because it's cheaper. Buying in quantity or bulk is cheaper. Why do they sell these for higher prices? First of all, it takes more to manufacture the bottles. It takes more to ship little things versus bigger things. The other reason is people still buy them. Who wants to carry this around to have a drink from? I could. It's a little bulky, kind of hard to carry. It's a lot easier to carry this around. That's why these things still sell at a higher price. This is 6 cents every ounce. This is 3 cents every ounce. So again, this is unit rates. You're trying to take something and make it into a 1. Now it's easily comparable because this is the same amount as this.